Verilog allows ports to be unconnected. For instance, certain output ports might be simply used for debugging, and you may not be interested in connecting them to external signal. So now let's assume a scenario that you have this Verilog module. This Verilog module. If you look at this module logic, how many input ports are there? Can you see? And how many output ports are there?
3 input, 2 output.
3 input ports and 2 output ports. What are the input ports?
ABC.
ABC is input ports. And what about M and S?
Output ports, sir.
M and S are the output ports. So this is a module definition or module instantiation?
Definition, sir.
So module definition. And what about this logic? My logic one, this one?
Invocation, sir.
Invocation. How many ports we have used in my logic one?
4, sir. 4.
4. And one is unconnected. Which one is unconnected?
So
C out.
No, the unconnected port is A1 is connected with A, B1 is connected with B, C1 is connected with C, and M is unconnected.
M unconnected.
Yes,
M is unconnected. So it means that you don't need this port. You don't need this port. So it means the total number of ports here are 4. 4 ports. 4 ports in module definition or in instantiation?
Instantiation, sir.
Instantiation. And what about in this example? How many ports are there?
5.
4.
5 ports. There are 5 ports. In the
Yes,
module
sir.
definition, there are 5 ports. In the module instantiation, there are 4 ports. It means one port is unconnected. It means that one port it means one port is unconnected. What is the name of that port that is unconnected?
M, sir.
M, sir.
M is not connected. So you can, maybe you don't need bit matching. It is illegal to connect internal and external items of different sizes when making intermodule connections. When we want to connect one module with another module, so you can use different signal widths. These are for the these are for the scalar data type or vector data type. Multiple bits.
Vector, sir. Vector data.
So multiple bits. So if we say so it means that if we are using multi-bit signals, they are typically vector data type. Vector data type. Okay. And it can, in these multi-bit signal can be of type reg or can be of type net. So these are two different type definition of type reg or type net. Okay. So you can use different sizes, like they can be of different sizes. So what is the components of simulation? What is the component of a simulation? So once a design block is completed, it must be tested. So the functionality of a design block can be tested by applying stimulus and checking the result. It is a good design practice to keep the stimulus and design modules separate. Okay. Why you need to test your design? Anybody?
Sir, to check our required results are obtained or not.
It's very good, very good. So to check that whether the design meets the specification of the user or not, whether it gives you the correct functionality or not. So this is called as functional simulation. In functional simulation, we verify or design in terms of functionality to see that whether it gives the intended output or not. So there are two different design components. One is your design block and one is the stimulus block. Stimulus block, you give different inputs to the design. You give different input to design and see that whether it is your design is correct or not. Now let's assume we have this module, my end, ABC. My end ABC. Please turn off your microphone. Please turn off your microphone. Somebody turn microphone is turned on. Okay. So now this is our design. Assign C is equal to A and B. This is actually your an AND gate. This is an AND gate. Okay. So the input are A and B and the output is C. What about A, B and C? These are module internal or external?
Sir, internal.
Internal.
A and B and C are module internal. And let's assume if we want to test our AND gate, this AND gate, how should we verify the functionality of this AND gate? Anybody? How can I test this AND gate?
So by applying different outputs at A and B and checking their outputs at C.
Different
Sir,
outputs.
Truth table के साथ compare करें.
Yes. So actually we apply different inputs at different time instances and check that whether it's correct or not. Now let's assume it's also like this, that first we apply 0, 0 at time t0, then we apply 0, 1, then 1, 0, and then 1, 1, and check its output, that whether the output is 0, 0 or 0. So this is actually a simplistic way to test an AND gate. Okay, now if you look at this AND gate, it is a design block or stimulus block?
Design block.
It's a design block. And what about the stimulus block? This is your stimulus block. Okay. So if you want to instantiate a stimulus block, so okay, so this stimulus block should be more external to the design block or internal to the design block?
Maybe.
External, sir.
It should be external to the design block. Okay. Now, so now let's see. So now we have defined a module test AND. Because it's a stimulus block. We want to test our AND gate, module AND gate. And this is your AND module. Module starts here, and module ends here. So this is the complete stimulus block. This is your stimulus. This is your stimulus block. Okay. Okay. Now, if you look at the stimulus block from the top, so we can see now. I can redraw it here. So now this is your AND gate. This is your AND gate. Your A input is A, your input is B, and your input output is C. So this is your module internal. And now if you look at here, so this is now we need a top module on the top of this module. So this is module is external, that is A, is B, just to differentiate in capital letters, and now it is capital C. So this is module internal. And now this is your stimulus block. This is your stimulus block. We call this as test AND. So this is, we call it as test AND. The name of this module is test. So now this is a module test AND. Okay. Now, if we have defined A and B as reg, A and B as reg, why we have defined A and B as reg? Can anybody let me know?
सर वैल्यूज चेंज हो रही हैं, टेम्परेरी वैल्यू स्टोर करवा रहे हैं.
Yes, I told you before that reg is a data type that stores a value. That stores a value until a new value is assigned. So if you look at here, so initially it should store a value of 0 and 0. So A and B are storing some value until a new value is assigned. That's the reason that we have defined the big A and B as of type reg. That's the reason that we have defined this as of type reg. And why C? Why C? So if you remember the port connection rule, from the previous lecture, if you remember the port connection rules, so this should always be of type net. A and B can be of type reg or net, but now we have defined it as. And internally, if you look at this, A and B internal, A and B can be reg or net, and C can be must be net. If you remember the port connection rule. So okay, now if you look at this port, my and one. What is this? Module instantiation or module definition?
Instantiation.
Invocation,
Module
sir,
instantiation. And what we are connecting? We are connecting signal A with small a, signal B with small b, and signal C, like the big C, with small c. Okay. And what we are doing now? A and B. So now we have assigned the value of A. It is the initial block. Initial block starts at simulation time 0. We already studied it. So it starts at simulation time 0. Simulation time 0. And after 100 time units, now you are changing the value of B to 1. After 100 time units, you are changing the value of 1 and B to 0. And after 100 time units, you finish the terminate the simulation. And then you are also using a monitor statement. G, what does a monitor keyword does? G, बताएं. Anybody?
So the changes को monitor करता है.
Monitor is invoked every time
There is a
Parameter changes.
when there is parameter change. What are the parameters here?
Values of A, B, and C.
A, comma B, comma C. And this A refers to %B, your AB. What about B? %B. And what about C? Okay, now if you look at this code, at simulation time 0, T0, what is the value of A? 0. What is the value of B? 0. What should be the value of C now? By looking at the design block.
0.
0, because if A 0, B 0, what should be the output? C 0, because it's the functionality of the AND gate. Okay, and after time 100, A still same, B changes from 0 to 1, output is 0. Similarly, 1 0, output is 0, and 300, output is 1. And at time 400, the simulation finished. So at time 400, simulation ends. Okay, so what happens if you define C as reg? Then it will violate the port connection rule. C cannot be as reg. So let's assume if I define this big C, not small c, big C should be of type net. That's the reason that now we have defined this C as wire. You remember? समझ आई बात या नहीं आई? नजर आ रही है आपको नहीं? We defined.
Yes, sir.
That's the reason, because it should be of type net. Any question? Any question?
Sir, wire और net एक ही चीज है, right?
Wire, yes. If you use the explicit keyword wire, it will be of type net. If you use input keyword, it is of type net. If you use output keyword, it is of type net. If you use in-out keyword, it is of type net. Until and unless you redefine the signal. नहीं बेटा, नहीं समझ आई बेटा. Okay, very good. Okay, so gate level modeling. Okay, Asad will conduct all of these classes in the lab. So actually, you can have this simulation framework in the VLSI lab. As VLSI lab, you can do every type of experiment in the tools that are provided. Okay, now we started with the gate level modeling. A logic circuit can be designed by use of logic gates. Definitely, logic gates. Verilog support basic logic gates as predefined primitive. These primitives are instantiated like modules, except that they are predefined in Verilog and do not need a module definition. Okay. So what are the gates? AND and OR gates. Okay. How do you define an AND gate in Verilog? Using which keyword? And actually, so there are two ways. There are two ways to define module. You can also use AND, by AND, C, A, and B. By AND, C, A, and B. Okay, what is AND? This is module definition or
module.
This is module definition or invocation?
Invocation.
Invocation. Okay, in Verilog, it is optional to use this my AND. If you don't use this my AND, doesn't matter. You can also use it like this. You can also use same AND, C, A, and B. Okay, so it allows you to instantiate. It is allowed to instantiate an AND gate without using the module, the AND gate name. Okay, so these are same.
Okay, sir.
You got my point or not?
Yes, sir.
Okay.
Got it.
Okay.
Got it.
So you can use AND gate, you can use OR gate, you can use exclusive OR gate, you can use NAND gate, and a lot of gates are there. Now buff and NOT gate. Buffer. What is the function of a buffer?
सर इनपुट और आउटपुट जो है सेम होता है हमेशा.
Output and input same होगा, but it boosts up the signal. It boosts up the strength of the signal. It is used as a buffer. It boosts up the signal. Okay. And what about NOT?
Invert
opposite.
It will invert it. It will invert it. Okay. So whenever you will use any primitive gates. So what are the example of primitive gates? You use any primitive gates in Verilog. What are the primitive gates in Verilog? Any example? AND, OR, choose your
NAND,
NOR, NAND,
NOT,
buff. See, all of these primitive gates, any primitive gate, primitive gate, you can use any function. The first parameter is your output, followed by the inputs. Okay. So if you look at this example, AND gate, what is the size of this AND gate? Anybody?
One output and four
One
inputs.
output is your output, and A, B, C, and D are the inputs. Okay. Any problem?
Yes, sir. No.
No, sir.
Okay, very good. Now, what about buff if and buff not if? Buff if and not if. Okay. So buff if is used to instantiate a tri-state buffer. Buff if is used to instantiate a tri-state buffer. So what's the format? It's a function. Function can be, what are different type of functions? Anybody? What is function?
Returning and not returning.
No. Buff if 1, you will use buff if 1, or buff not if 1, then buff if 0 and not.
सर इसमें एक इनपुट होगा जो डिसाइड करेगा कि
Yes.
जो
So if
इनपुट
you look at
आउटपुट
the-
है उसको
yes.
क्या करना है.
Yes, if you look at the function, the first parameter is your output. It is your output. The second parameter is your
Input.
input. And what about the third parameter?
Control.
Control. So I will
Sir?
give you an example. जी बेटा.
सर नॉर्मली जो प्रिमिटिव गेट्स हैं उनमें पहले नहीं सही है उसमें भी पहले आउटपुट आता है.
Every time there is output, then inputs.
ओके.
But
सही.
But if you look at the buff if and not if, so actually there are 3 terminals. One is the output, second is your input, and third is your control.
Control.
It always have 3 terminals. Okay, it cannot have more than 3 terminals. So if you go look at this example, buff if 1. So what is B in this example? B.
Output, sir.
Output. What is A?
Input, sir.
And what about cell?
Control.
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 Very good. So if you look at this, now, if you look at this tri-state buffer above, can you see the tri-state buffer here?
Yes,
Yes.
sir.
B is your output. A is your input, and
Yes,
cell is your control input. It is active high or active low?
Active high.
Active high. Why active high?
तो जब ये 1 होगा तो
बार
तब
नहीं
ये
लगा हुआ
करेगा.
सर उसके ऊपर.
Active high. Now, buff is 0. If you look at buff is 0, the control input is now 0. The F is 0. So if F is now 0, it's the control input is 0. So it is enabled. So actually, if you look at this diagram, so the diagram will look like this. The control is active low. And what is the name of the control signal here? F. What is your input? And your output?
C.
D input,
Sorry,
C
output.
D and C.
Output is E, not D. It is E actually. Okay. Output is E. Output is E. What is your input?
D, sir.
Now if you look at this, not if 1, the control is active high. Active high. But not, because if you are using a not, so actually it will invert an input. So actually the not is at output. बेटा समझ आ रही है या नहीं आ रही समझ?
आ रही है सर.
Okay. And not if 0, if you are using not if 0, then the control is also active low and the output is also active low. समझा बेटा?
सर अगर मतलब 0 होगा कंट्रोल पे तो तब वो इन्वर्ट करेगा इनपुट को.
Invert करेगा. It will invert, X will invert W.
Okay.
Okay, so now if I'm looking, if we use it like this, I will explain this. Now I will explain this. Now let's assume if I'm using not if 0 X U and Z. So what will be instantiated in hardware? It will look like this. Because not is at control 0, output is inverted, X is your output, your input is W, the control input is Z. So you can say if Z is equal to 0, This implies that X is equal to invert of what?
W, sir.
Invert of W. Else means Z is equal to 1. Am I right? What will be the value of X?
X
Anyone?
equals to
W,
X.
sir.
X ही
What?
होगा जो normally.
No. No.
So W equal
Z.
W
Z.
होगा sir. W.
No. No.
X. Don't care.
No.
The high impedance.
High impedance,
High
sir.
impedance. It's a tri-state buffer. I
सर
told
वो
you
Z
that.
बोला था ना इसीलिए हाई इम्पीडेंस को Z
No,
कहते हैं.
tri-state buffer. It will be X will be tri-state. Z is the control signal. It's the name of the control signal, man. It's the name of the control signal. Got it?
Yes, sir.
In all of the tri-state buffer, if it is active high, active enabled, if it's enabled, the output will be equal to either the input. In case of buff if you're using not if, it will be the invert of the input. And if it is disabled, output will be tri-state. That enabling or disabling depends upon whether it is active high enabled or active low enabled. मेरे समझ आ रही है या नहीं समझ आ रही है?
आगे सर.
समझ आ रही है.
Now we also studied in digital, in embedded system. If let's assume if we have used a bus, okay. So I will now finish here. Let's assume we have this bus. In 1, in 2, in 3, cell 1, cell 2, and cell 3 and bus. Can anybody explain me how it will work? Anybody?
सर जिसका कंट्रोल 1 होगा वो वाला जो इनपुट होगा L N1 N2 N3 वो वाला बस पे आउटपुट पे चला जाएगा.
So if you look at a truth table, can I write it like this? Can we write that like cell 1, cell 2, and cell 3, and now bus. So if all of them are 0, what will be the output?
High
Tri-state
impedance.
buffer.
Tri-state. Very good. Tri-state. Yeah, it will be in the high impedance. It is in high impedance. It means that no device is driving the bus. Actually, bus is a shared resource. Now, in this example, the bus is a shared resource, and it has three. Let's say we have connected 3 devices. What is the name of each device? In 1, in 2, and 3, we have connected 3 devices with the bus, and only one device can drive the bus. One device can drive the bus. Okay. Now, if let's assume if its cell 1 is 1 and 0 and 0, what will be the value of bus?
N1.
In 1.
Yes.
If in 1 is logical 1, the value of on the bus will be logical 1. If in 1 is logical 0, the value on the bus will be logical 0. Okay. 0, 1, and 0. Then
And
in 2
N2.
will be driving the bus. And if it's 0, 0, 1, who will be driving the bus?
N3.
LN3, sir.
In 3. Okay. Now you should take care that no 2 devices should be enabled at a time. Means that who will then drive the bus? That's the problem. Now I will give you an example. Let's assume if this is 1 and if this is 1, both are driving a bus, and let's assume there is a logical 1 here and logical 0 here. What will happen?
1 ही आएगा बस पे.
No, Okay, it is also driving the bus with a value of 1, and it is driving the bus with a value of what? 1 or 0?
0.
What will happen?
शॉर्ट हो जाएगा पता नहीं
Yes,
कैसे।
it will be a
Zero
short
हो
circuit.
जाएगा।
It will be a short circuit. नहीं बेटा, समझ नहीं आ रही आप लोगों को।
आगे है सर।
आगे
One
Sir,
device
आगे
is driving a logical 1, another is logical 0. One is VDD, one is 0. Resistance is 0. What is I?
infinite sir.
V divided by R. The difference is VDD. One is driving VDD, other is 0. And resistance is 0. Short circuit. So actually, whenever you want to design a bus-based system, you must ensure that only one device should drive the bus at a time. In embedded system, I have taught this in embedded system. Maybe you have. So only one device should be allowed to drive the bus. Okay.
Right.
Okay. Now actually, now we want to write the code for this schematic. We want to write a very long code for this schematic. How can I write it? Which primitive should I use? E.
Of if one.
Of if 1.
Yes, sir. Buff if 1.
What is the output?
Bus.
Bus. Then what is the input?
In 1. In 1.
In 1. What is the
and
control
cell
signal?
one- Cell 1.
Set 1.
Then how should I write now? Buff if 1.
1.
Okay. Then what should I write?
Bus in 2
Bus
and cell 2.
bus is in 2 and cell 2. And buff if 1. Bus, comma, in 3 and cell 3. And actually, if you look at this, okay, no, don't look at the schematic above. Don't look at the schematic above. Just look at this one. Don't look at the schematic above and just look at this code. What will be instantiated using the first statement? Can you see the first statement? Just look at this code. It will instantiate a tri-state buffer. Am I right or not?
Yes, sir. Yes.
Bus is the output. In 1 is the input and cell 1. And if you look at the second one,
सेम ही होगा बस cell 2 और in 2 आ जाएंगे.
cell 2, in 2, and bus. Am I right or not? And if you
Yes.
look at the third one,
Cell 3 in 3 और bus.
bus in 3 and cell. Am I right or not? But if you look at this code, the bus has the same name. When a signal has the same name, what should we do now logically?
Wire.
Connect them. Not wire, connect them. When
Yes, sir.
they have the same name. नहीं समझे बेटा आप?
Connected
So
होने
it is
चाहिए.
connected because same name. But these are very small details, but you should look into the details of the code, and then you will learn and understand. And it's my request to everybody to write the code on your own, and actually you will identify your own mistakes. Okay, beta? Should I proceed now?
Yes sir.
Okay, now this is in half adder. If you look at the half adder, this is the half adder. This is the module. So if you look at the module, okay, I have not written the name of the module. I should have written the name of the module. Half adder. Half adder. If you look at the block diagram, what are the inputs? A, B, C, sum and C out, and this is actually the implementation of the hard level at which level of abstraction? कौन सी level of abstraction है?
Yes sir.
कौन सी लेवल ऑफ एब्स्ट्रैक्शन है?
Gate line.
गेट लेवल. So this is at the gate level abstraction. Okay, so the output is sum and C out. Input is A, B, C in. We have defined 3 wires M1. This is M1, M2, and M3, N1, M2, and M3. Now exclusive OR M1, M1 is the output, A and B is the input. Exclusive OR sum is the output. Input is M1 and C in. And then look into the E. Now there is a problem. Now we have a small problem. Design a 2-into-1 multiplexer using the following schematic. Can you? Now this is a schematic. This is a schematic. Can you see the schematic, beta? नजर आ रही है आपको schematic? In the purple color.
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
Okay. Now, if you look at this schematic, actually so how can we write a code for it? Can anybody let me know how can?
Yes, sir. इसमें सर schematic गायब होगी. जी.
नहीं. How can we write
Sir,
code for it? Module?
Buff if
सर
Buff
दो
if
buffs
one.
आएंगे.
No. Start from a module. Start from module. Module.
Okay.
Module mux. It is the mux. Okay. Module mux. And module.
In 1 S and 0 inputs हैं और out इसका output है.
1 S and in 0, and out is
Yes,
your
Yes,
output.
sir.
Am I right?
Yes.
Yes,
जी.
sir.
What is your input?
In 1 S
In
and
one
in 0.
In 0.
Output out.
Actually, Verilog is case sensitive. That's the reason that I'm writing everything in say case sensitive. The objects or the variables can be in capital, no problem. But the keyword must be in case sensitive. Okay. So output.
Output out.
Out. Okay. If you look at this schematic, okay. Now, if you look at this schematic, there are 2 buffers. Can you see?
Yes, sir.
Buff 1 and
Buff two.
Buff 2.
buff 2. Okay, now if you look at there, so let's assume we are what is the name of the control signal here? S.
Yes, sir.
Yes, sir.
Okay, when S is equal to 0,
So buff two.
when S is equal to 0, which buffer will
Buff-
be enabled?
Buff 2, sir.
Buff two, sir.
Adding 0, sir.
Buff 2 enabled. Am I right or not?
Right, sir.
Yes, sir.
Yes, sir.
And what will be your output?
So
In-
output
in
will
zero.
be in 0.
In 0, sir.
Output will be,
In 0.
In 0.
and if S is equal to 1, which buffer will be enabled?
Buff 1.
And what will be output?
In 1, sir.
In 1, sir.
So this is the functionality of a multiplexer. It's a
Yes,
select
sir.
line. It selects between two signals, a logical 0 or logical 1. So this is the schematic of a multiplexer. So now this is a schematic of a multiplexer. S is on the select line. The output, what is the name of the output? Output is your output.
Yes, sir.
And if the input is 0
In 0.
and if in 1, am I right or not?
Right, sir.
Yes, sir.
Okay. So this is the functionality of a multiplexer. And we want to implement this multiplexer using tri-state buffer. When one buffer is enabled, other is disabled. When other is disabled, the other one will be enabled. Okay. How can I
Yes,
write
sir.
the code for it? Anybody? How can I write the code?
Buff
Module.
if 1
Buff if
Buff if 1. Buff if 1. Very good. Buff if 1.
out.
The top one.
Yes,
Out.
sir. Out.
In 1
Output is
S.
your output. And then
Yes.
in 1.
1 and S.
And then
or S. S.
S.
Yes, sir.
What about the second one?
Buff
Buff if
in-
0.
0. Very good.
Out
The same
in,
output is
in
connected.
0 and S.
0.
Yes,
0
sir.
and
S.
you have to write both in small. Okay, buffer. Why small? Why small?
Because
Case
case
sensitive.
sensitive.
Because Verilog is case sensitive. All the keywords, must be
Lowercase.
lowercase. What about the identifiers?
They can
वो
be
कुछ भी हो सकता है.
This is
Lower or upper.
identifier. Identifier. They can be
Lower or
either
upper.
one of them.
Upper
Upper
or
or
can
lower.
be upper or lower, no problem. They can be upper or lower. But note that it's also important. It's very important that this input A and output A are different signals, not the same signal. नहीं समझे बेटा?
आगे समझ
समझ
सर.
गए।
Yes, sir.
जाओगे.
आगे समझ.
So these are not same signal. याद रखिए अगर same होगा तो क्या होगा? Correct होगा या नहीं होगा?
Incorrect होगा सर.
नहीं, incorrect नहीं होगा. Correct होगा. एक दो they will correct each other. नहीं समझे बेटा? यहाँ पे जिस तरह हमने same, they will connect. Okay, so they are different signal, not same signal. They are different, not same, because Verilog is a case sensitive. Okay. Okay, now data flow modeling. In data flow modeling. For very small circuit,
Sir.
the gate level modeling approach, जी बेटा.
सर काफी टाइम नहीं हो गया.
5 minutes, only 5 minutes. Okay.
चलो सही है.
Okay. For data flow modeling, for small circuit, that gate level modeling approach works very well, and designer can instantiate and connect every gate individually. For small circuit, not a problem. But complex design, in the design become more complex. The number of gates become very large, so it's very difficult to design a complex system like microprocessor at the gate level. So actually, designer can design more effectively if they concentrate on implementing function at a level of abstraction higher than the gate level. Okay, so what Verilog does? Verilog allows a circuit to design in terms of the data flow between the register. In terms of the data flow between register. How? We will use some kind of assignment. We call it continuous assignment. Okay. A continuous assignment. A continuous assignment is the most basic statement in data flow modeling, and it is used to drive a value on a net. If you want to drive a value on a net, what is a net? Net? Anybody?
Net is a variable.
No, net is a data type.
Data type, sorry.
Data type of a signal. A signal can be rec or net. I already explained that net is actually a connection between hardware elements, and it needs a driver.
Yes, sir.
If you remember, okay. So what about the continuous assignment? The continuous assignment have the following characteristics. The left hand side, what is now we have a continuous assignment, we have a left hand side and we have a right hand side. The left hand side of the continuous assignment is always net. Okay, it is always net. The left hand side must be scalar. What is scalar? What is scalar?
So one bit.
Single bit, sir.
Single bit. And what is vector?
Multi-bit, sir.
Multi-bit.
Bits.
So the left hand side must be a scalar or a vector net. It can be a scalar or vector net or a concatenation. Concatenator I will explain it later on. Continuous assignment is always active. Always active. Whenever anything on the right hand side changes, the left hand side is evaluated as soon. What about the right hand side? The operand on the right hand side can be rec or net. Can be read or net. Okay, now what are different examples of a continuous assignment? How does continuous assignment? Continuous assignment is always used with the keyword assign. So whenever we see assign keyword, what does it imply?
Continuous assignment.
It is a continuous assignment. Okay, if I say assign out is equal to I1 and I2, if I write it like this, assign out is equal to I1 and I2, what does it imply? What is the name of this assignment?
Continuous assignment.
This is continuous assignment. What is the left hand side?
Net.
No, in this example, what is the name of the signal on the left hand side?
Out.
Out. What should be the type of out?
Net.
It must be net. What is on the right hand side?
I1 and I2.
I1 and I2. What can be type of I1 and I2?
Reg
Net
and net.
or
Reg
net.
or net.
It can be reg or net. जी बेटा समझ आ गई?
Yes, sir.
जी,
Any
sir.
question?
No,
No,
sir.
sir.